Hi, my name's Jim Sebastian with Matt Block and Taylor Cameron. The three of us teach science here at Pinewood, and I'm going to go over some of the things that the kids need to understand for the FCAT in May and how you can help them understand more at home. So what they need to understand are three major areas. The first one is physical science, which covers a whole bunch of areas that we do a lot of hands-on, not as much as we have done in the past, but we have a lot of hands-on things that we do here. As long as I keep the kids safe and separated and they can do them one-on-one, then I try to do as much hands-on as I possibly can. And Mr. Block and Ms. Cameron do the same thing. The second area is earth science, which covers earth, space, rock cycle, landscape, earthquakes, volcanoes, and all the material that happens on the earth and space. And I have some things I'll show you what the kids have been doing in space. And the third thing is life science. We talk about biology, the difference between plants and animals, how plants and animals interact to each other. So I'm going to move to my right and show you something here in sound and light that we study. When we're doing physical science, we do get into the energies, sound, light, electrical energy, kinetic energy, mechanical energy. This here would have to do with light over here. This would be like reflection. They would have to know the difference between a reflection and a refraction in light. That refraction, which is done with a prism, when you pass a light through it, it does tend to bend the light, and it'll be over there somewhere when you see it. And reflection is when you reflect the light, and we use the lasers. The kids love the lasers, and I can bounce it off Mr. Williams right here. Office, there you go. So we do with light. If they can do it, they can understand it. The kids have a problem with this until they do it. They will mix this up with this. So they will not know the difference between refraction and reflection, and they will just go ahead and just guess on the test. And I'm trying to get them to where they're not guessing anymore. These are tuning forks, and they are for sound. Each one of them has a different pitch. If you went by the scale, this is a C note, and this would be an E note, which would be higher in sound. Okay, so you have the sound that we work through, and that vibration is what sound is, and that the closer the vibrations are together, the higher the pitch will be. The further away the sound waves are, the lower the pitch will be. And they can work with all of this and get understanding it is what they need to do, so that when they take the test, they know that a reflection is what they look at in the mirror. And they know what a refraction is that it is a rainbow, that when water is falling and the light comes through the rain, it bends the light and we have our rainbow. Hi, welcome back. We're doing electricity. The kids have to understand electrical circuits. They have to know when an electrical circuit is open, when it's closed, what that means, and they have to be able to generate an electric circuit and light up a light bulb. In the circuit, they learn that it means a circle, so if they don't have their wires connected properly, then they're not going to complete the circle, and they won't have any electricity coming through the light bulb. There's things on the table here that they use to differentiate between a conductor and an insulator, that if they touch one of these items with their wire, if it lights the bulb, it would be a good conductor, and if it doesn't light the bulb, then it would not be a good conductor. We do have a lot of mix-up in this, like some people think that glass is a conductor, which it's not, but we work through those by letting them work with the material in their hands so that they can sit and have an organizer, so that they can list the things that are conductors, so that they can list the things that are insulators. These are the materials that I would use to set this up. Then they would do the connection, and once they have the light connected, I let them connect to another table, and to see if they can get 2 lights lit. And can they keep the circuit alive and get 3 lights lit. Also in the physical science, these are the tools that we would use to do physical science. They have to know what tool to use for what thing that they're going to be doing. There are microscopes, and there's waves, and there's measurement tools here, and there are temperature gauges that each of the kids use so that they understand the difference between grams and ounces. In science, we do use metric, so we're talking about grams in all of these machines, and the thermometers and everything are geared towards metric. Earth science has space in it, so we take a look at space, we take a look at the moons, we take a look at the eclipse, we take a look at the inner planets, we take a look at the outer planets. Some of the work that you see here are what the kids have done. We also, on Earth itself, we have earthquakes, we have volcanoes, we have hurricanes. These are the things that we study to help them understand what happens during an earthquake, what happens during a volcano, what happens during a hurricane, why they need to have an escape plan during a hurricane here in Florida so that all the family gets out safe if they have to. I do keep a small library in the room so that they can take a look at the books and read about the books. These are all accelerated reader books so that they can get the points from it from reading them. So today we're doing chemical changes, and yesterday we worked with yeast to show chemical change with yeast, that it changed its color, that it warms up, that it bubbles. And then the kids were asking me about bread, and since my family happened to be bakers, I told them that today I could bring the flour and stuff in, and I would let them work with chemical change. And this is what I talk about when I talk about the kids handling the stuff and learning it. They will never forget chemical change once they've made their own bread. And today we made our own bread, and here right now they are sitting around and they are in their second proofing. They have taken them out once already and kneaded them and taken the bubbles out, and now they put them back in so they can proof them for the rest of the day. They have been instructed, and their parents have also, that they are not to eat the bread, that they are to take it home, throw it in the oven for a few minutes and let it brown up, and then if they will take it out when it cools, cut it open. They will see inside, if they have taken the bubbles out by kneading it correctly, then they will have a loaf of bread with small bubbles, and if they didn't do such a good job, they will have a loaf of bread with larger bubbles. So when we are doing physical science, I try to do as much hands-on with electricity, with light, with sound, with chemical change that I possibly can do. Each of us does that, and of course the testing is there. And what I tell my parents is how you can help them at home is to try to make science real for them. Everything in your home that you use is science. Electrical science, you have the stove, you've got your refrigerator, you've got your video, you have light, you got your sound, you got your TV on, so you have light going into that, you have light coming out of it. So if they realize that this is stuff that is outside my classroom, not just inside the classroom, then they will better understand what science is, and they will be better science people. I have an example of the type of question that they're going to see on the FCAT in May. There are 60-some questions on the FCAT test in May. This is just one glimpse at one. But all of the tests, all of the questions have to do with thinking. They are all multiple choice. However, they all have to be thought out before they choose their answer. There are 4 answers in the multiple choice. 2 of them don't belong here. In all of our multiple choice questions, they give you 2 red herrings, 2 questions that don't belong. They give you 1 question that's a distractor, and they give you the answer. So if you read the question and you understand what you're looking at first, the analysis is here for them to go down below and pick out the correct answer. This one says, below is an illustration of the circuit. What will happen when the switch is closed? This is the switch. So when we close the switch, what will happen? And then you have your answers here. The buzzer will start to sound. The buzzer will start to sound and the light bulb will light up. Since there's no power source, nothing will happen. Since there's only one switch, nothing will happen. The distractor is right here. The buzzer will start to sound. So when you close the switch, yes, the buzzer would sound. However, there's no power source here. There's no battery. So if the kid is just jumping to the answers and not reading the question thoroughly and understanding what a circuit is, then most likely they're going to take this answer rather than this one. So we developed that study habit where they have to read it, understand it, and then make their selection. Get rid of the ones that can't read, and then make their selection. It's a long process. The kids get it. They work with it. They understand it. We're thrilled to have the kids. They work very hard in science. And I guess that's what I have to say about science.